Hello everyone and welcome back. My name is Bernard von Oppeln. I'm a Master Dental Technician here at Formlabs, and this is the third episode of my little series about removable dies models using Precision Model Resin and the Form 4B. Before we actually go into the real cut design using 3Shape or Exocut, I want to teach you some basic knowledge about the design of removable dies models. We're going to cover the following topics. We're going to look at hollow models versus solid models. We're going to look at ejection pins and the usability and functionality of ejection pins. We're going to look at how to add drain holes to a hollow model. And finally, there's a section about the three main parameters that control the friction of a removable die in a restorative model. Let's get started. So at Formlabs, we always recommend you to print your restorative models directly on the build plate. Let me explain you the three main arguments for it. The first argument is actually related to the print process. When you're printing a model, you're printing layer by layer. And if you're printing flat on the build plate, you have less layers to print, which means your print is going to be faster. For the same reason, for less layers to print, you're also going to consume less resin. And the third argument for it is actually there's nothing sturdier than the build plate itself to support your restorative model during the print. So I know that a lot of you guys out there like to print your models hollow to consume even less resin. So if you put such a hollow model directly on the build plate, you run into a problem which is called a suction cup. You see this in this animation. The hollow area of this model is what we call a suction cup. Let me explain to you why this is not a good idea. So imagine this is your tank, this is your hollow model, and the liquid is resin. During the print process, your build platform will move up and down, and up and down, and up and down. If you look close at the level, also in the glass, you see you have under pressure, over pressure, under pressure, over pressure. And that's a bad thing for your print, and it's going to impact the print accuracy. The easiest solution to prevent the suction cupping effect is opening this cup by a little hole. And that's what you're going to do in your cut software, be it Exocut or 3Shape or anything else. In this section, we're going to look at some design specifics of a removable die. On this picture, you see what is called an ejection pin on the bottom of the dies. That's very convenient if you want to push out the die out of the model just by using your finger. But this also means you run into another problem. So here you can see what is happening. In most cut softwares, the little step between the ejection pin and the die body is a fixed value. So this means it is always the same step, no matter what diameter your die is. And this is why with this little super tiny die on the right here, you will have a more or less unprintable ejection pin. In this image you see how a die from a Formlabs library looks. That we omit the ejection pin. You still can push out your die easily using a tool, but you will not have print problems because of the tiny ejection pin. Another thing that is relatively new in CAD software for removable dies is that these dies have a taper. A taper is going to help us adjust the friction and have an easier insertion. In this last section of our little video, we're going to look at the three main parameters which are controlling the friction of your removable die. The first being the cross section or diameter. The bigger your die is, let's say for a molar, the more surface you will have for friction. The more surface you have for friction, the higher the friction will be. The second parameter is the length of the die. Similar to the cross section, the longer your die is, the more surface will be in contact and will increase the friction of your die. And the last parameter of these three is actually related to the print process. During the print process, you will build your model layer by layer. If your insertion axis for the removal die is perfectly aligned to the Z-axis of your print, no problem. But as soon as you're inclining your insertion axis a little bit away from the central Z-axis of your build direction, you get these little steps. And these little steps, they're actually working like sandpaper. They're increasing your friction. So you know everything you need to know to do a proper design of a removable dies model. In the next section we're going to look at how this works in ExoCut. See you there.